What you see here is an invisible beam of gamma radiation coming out from that small pipe in the corner, and this device I made that allows me to see it. It glows bright orange exactly where the beam hits the device. And in this video I'm gonna show how I made it. So the other day I was playing around with Soviet junk and found out that this SBT-11 Geiger-Müller tube is quite special. Yeah, when turned on it glows bright orange, which is very much unexpected, but really cool. And when biased properly it can still work as a counter. Here I'm testing it with this thoriated tungsten rod, which gives out about 5 times the background radiation, which is not much but noticeable and enough for testing. And yeah, we can see where particles hit the sensor. For the next experiments I'm gonna use my X-ray machine. How to make it I have another video. And as expected, when bombarded with X-rays, the device glows continuously. But I need to confirm that those flashes are not random, so here I'm using this lead equivalent glass to block one side of the sensor and leave small open side to confirm that flashes indeed occur on the open side, not in the closed one, which is true. So when I confirmed that device works as I expected, I made it a 3D printed body. Design is modular. This is the scheme, only a couple of components. Pretty easy, right? Here's the sensor, its socket. Off-the-shelf high voltage model. A charger with the adjustable step-up converter, so we can adjust sensitivity using it. This mesh protects delicate mica window on the sensor from breaking because it's extremely fragile. The whole device can be assembled as easy as that with one hand. Let's put it inside the body. Here I'm assembling the device. It can be charged like this, and here's the final result. I think it looks pretty good, and it's pocket size, compact. Yeah, let's test it more. Here I'm using the same tungsten rod. We can see flashes. It also produces audible clicks, which is really cool. Yeah, for next experience I realized that I don't need the full power of my X-ray, so I set it to like 1%, and at this setting the normal Geiger counter doesn't even register it, but my new one is quite more sensitive and it does. So yeah, I'm making some more experiments. Okay, this is the most interesting part, so I improvised that aperture for my X-ray that allows me to produce a narrow beam of gamma radiation, and this is where this device really shines, because we can see the exact spot where this beam hits the device, and that's the whole point of it. This device is here for safety. Yeah, this device is really cool. It's like a small spark chamber, but it's pocket size. It's sealed. It fills with neon. It's always ready to work and shows you exact beams of radiation. Here I'm showing that my aperture is not perfect and some radiation is leaking from the bottom. This is also where this device is pretty handy, because it allows you to see the leaks. Not every Geiger counter is capable of that. I don't know why nobody uses it like this. I think it's very, very convenient. Anyway, this is the end of this video. I hope you appreciate my effort. Please leave comments, tell me what you think, ask questions. Yeah, all 3D models and the list of components will be in the description. This project is kinda DIY friendly and I think everybody can do it. I hope you liked it. See you around.